It's like you're the only one who's online.
Oh, it's only me.
I cannot see any other person.
I can see only 2 participants. Let me remind them in the group.
Okay. So you're now 3.
I can see Claire and Sam.
Did you manage to do anything on this biasing methods? Plus also the example I'd asked you to do.
I did the example.
That exercise.
Yes, the exercise. There were changes on RB. RB, there was one for 1 mega ohms. And the other one was 5 kilo ohms. Yes.
So did you do the one? I think I had given you 2, and there was one which was for this question here, for this base bias with the meter feedback. That concept.
On the last two exercises that you gave.
One was meant for this.
I might have missed that. Maybe when there was that disconnection. Is it the one that had The 5 kilo ohms on RB.
Yeah, that is the one. In fact, I think we can relate those values as we are relating them,
Yeah.
so that when they come, we can just start straight away. So I'd given you some parameters. VCC was 10.
VCC was 10 volts.
10 volts.
Then RB
was
5 kilo ohms.
5K.
Yes. Yes.
RC was?
And RC was 4 kilo ohms.
4.
And then we had beta at 100.
Yeah, beta is 100.
Yes. And of course, our VB being 0.7.
RE is?
RE.
Yeah.
RE was also 4 kilo ohms. That's what I think I recorded here. 4 kilo ohms.
4 kilo ohms, eh?
Yes.
And then, no, RE should be so. I'm not sure, but it
should be 6.
Who can remember what you had put down for RE?
What I recorded is 4 kilo ohms, unless somebody had a different figure.
Was it a 1 kilo ohm somewhere or 2 kilo ohm?
No, I can't. Claire, what did you capture?
RE was 4
kilo ohms.
RB was kilo ohms.
RB was?
5.
RC?
8. Two.
RC was 2. Yeah, because I also thought I had given a value like 2 somewhere. Is there anything else that you are required to get here? I think that's all. Then I'd ask you to do to get the current IB, IC, IE, then you get VC. Yeah, I think those are the ones which I required you guys to get. So,
yes.
Did you try to get the values for this? What were you getting for IB? Anybody who tried the question? So, with this one, what can you be able to get? I think we can be able to get IB based on the fact that VCC is equals to IC, not IC, IBRB.
IE.
IBRB plus VBE plus IE RE. Yeah, it's possible to get, actually it's possible to get IB from here. And this is what you do. You take the equation of VCC is equals to the same, you can just copy this one, and then we paste there. And instead of putting IE here, we put, you can put, IE over beta. Actually, it will be IB times beta. Because these two, it's not times beta, it's actually times theta. Let's just indicate theta to be O.
Theta.
This is theta.
Okay.
And remember, theta was given by IE over IB. Can you remember something like that? Which is actually approximately, you could change this to beta, because if you approximate, you can say beta is equals to theta almost. They're almost the same. In most cases, just approximate. And in that case, then your IB from here becomes what? VCC minus VBE, all that we divide by, so take that, divide by RB plus RE. RB plus RE, and that should be in brackets. So like this. So if we substitute the actual values, then you're going to have IB is equals to 10 minus 0.7 into brackets, and then you divide by the sum of the two resistors, 5K plus 5K plus 4K. That should be 9K. That would be the same as 9 times 2. Yes.
5 plus 2. 5 plus 2.
You're adding RB plus RE, not RC. Unless you change the value of RE to 2. Max, which one did you take it to be 2? Was it RE or RC?
RE, so it's 4. RE is 4. Yes, so it's 9.
Okay.
RC is 2.
So give me the results. Taking our calculators.
That should be 1.03
milliamperes.
Yes.
It's a very high value anyway. Actually, it's a very high value. Did you really calculate this? I would want to change it.
Sorry?
Is there any person who had calculated up to completion? Anyone who did that question up to the end? So I would want to change this value of RB to 500K. And then this becomes 1.03 times 10 to the power. No, anyway, it will be a different value because this will be 509. So 509. If you take 9.3 divide by 509 becomes 1.83.
Yes.
So 1.83 times 10 raised to power 3 to power 5 power negative 5. That's the value that you're going to have for this. Hey, you guys, there's something you have not done. You can't see this is supposed to be 100. So you might not even require to change this. that's sorry for the what you had not noticed. In fact, it's supposed to. You remember there was a beta here.
Yes.
I was wondering. So you're actually supposed to multiply by beta here. So let's not even change that value to 500. You can just have it as 5. Otherwise, that way it will get some good values here. You know, IB is not supposed to be in the milliampere range. That would be a very high current for IB. It can actually damage the transistor. So usually when you are designing an amplifier, these are some of the things you look at. So basically then this becomes 100 times 9. 100 not times 9, 100 times, because our RB, let's complete this one. It will be 5 plus 100
Times 4.
Times 9, times 10 to the power 3. Or we can just have all of them together like this. Bracket and this one in brackets. And that way it will be okay. This is not
Why 9 should be 4?
Should be 4. So that comes to 405 times 10 to the power 3. So let's use that. 405, 405. So our current will be 2.2, actually 2.3. 2.3 times 10 to the power negative 5 amperes approximately. That's what we are supposed to have. Are you guys confirming that? Mohammed, are you confirming?
Yeah, I'm confirming.
That's what we are supposed to have.
Yes.
Yeah, so these are the amount of IB. Then how do you get IC? Beta times. Beta times IB. Then becomes which becomes 100 times this value here, which basically gives us our IC to be equivalent to 2.3 times 10 to the power negative 3. Which usually, in terms of milliamperes, is actually 2.3 milliamperes, which is a very good value for IC. Usually that's what we indicate. And then, now let's do the value for IE. That should also be very easy, which is IC plus IB, and effectively you are going to have this value plus the other value. So that's the total we expected to get. If we take it, if we complete it, then you're going to have 2.3. 2.3 times 10 my calculator is not I want to get this anyway I think it will work. So times 10 raised to power -5 plus 2.3 times 10 raised to power -2.2 2.3
2-3 times.
the amperes. I think somebody had already, you have given the answer on the side. I want to do that's what you're giving in the chat. Oh, Emmanuel and Christine still not, Christine not present. Emmanuel, okay. It's okay. Then let's get the BC. I think that one now you guys you get to pick up BC. Calculate the value of VC. I give you a few minutes to do that. So VC will be VCC minus ICRC minus IERE, and that should be equivalent to ICRC. If you take your IC is this one, 2.3 times RC is 2K, so 2, and you realize they will cancel out. Actually, when you do it this way, they cancel out. And then the other one is 2.323 times RE is what? RE is 4. Wow. That value becomes negative. So just get it to be a negative value. But you realize that our transistor will be operating in saturation. That's what it means by getting a negative value. So 2 point. So 2.3 times 2 plus 2.323 times 4, that should give us 13. So minus from 10, that would be 3.89, negative 3.89. And please note that when a situation like this arises, you say that your transistor is operating in saturation region. So transistor in saturation. So please note that that's what we have for that question that I had given you. Actually now, because we have used exactly the same values which we have not changed, this is what I expected you to have gotten if you are done it. But unfortunately, I think most of you didn't manage to do it. Or actually none of you did that. Or if you did, Collins, what did you get?
Sir, I actually had different figures for, I had a different figure for RC. That's why I've got different values.
Why I used a different figure? What about Mercy? Mambia, did you try?
No, I didn't manage.
Yes, we are okay with that one. The way we have done it, are we okay?
Yes.
Yes, yes.
Because we are just using these equations that are here. And you see, I've picked on these two. Actually, we have been able to use these two equations mainly. So that's how you handle that question. Now, if you look at the next section, it will be about the other biasing methods, which I think we will not do an example on them. We have done those two examples. I believe have grounded you well in this representation of biasing methods. The best bias with collector feedback, usually you have the resistor here, and then you connect your, after RC, that's where you connect your RB2. And that's what gives you the emitter feedback. If you form equations here, those equations will be given by VCC is equals to IC plus IB in brackets times RC, which is basically IE times RC, plus IBRB plus VBE, then you go to ground. And that equation would be VCC plus IERC plus VCE is equals to, or it actually takes you to ground. And these are the equations which are given here. VCC, IC plus IB, which is IE times RC plus VCE. And the other one is VCC, ICRC, which is IERC plus IBRB plus VBE. And that's what you have seen. The other equations are not quite important, but it's okay. You can also understand what they represent because one of them, VB is from here to here. VC is from here all the way down, grounds. VC, we already know it's just the collector emitter section. So that's what you are supposed to have. And the base bias with collector and emitter feedback. Now this combines the two feedbacks, the collector and the emitter, in which case the equations we have up there, just add IERE to the two equations. You can see this one we have added IERE, this one we have added IERE, and the equations will now be just a slight difference because you have just added RE. If you go to the next one, you find, please note that I'm not talking about there's something that we are calling the stability factor. I'm not talking about that, so you don't need to worry about it. So the next one will be the best bias with two power supplies. That's what we are seeing here. And our equations that we are going to pick from here are basically that you can actually have VCC is equals to ICRC plus VCB plus IERB plus IBRB, sorry. And the other very important one is VEE is equals to IERE plus VBE plus RBIB. So that's the equation we have here. This one, VEE is equals to IERE plus IBRB plus VBE. This one, I think we might not include it. I don't think whether we need to have this because it does not form a loop. Unless you are forming a loop, that's when you will have this kind of equation. I think that one you don't need to include it. So if you go down, you find that we have the last bias, which is usually very important because it's the one we apply in most of our applications in electronics. We call it the voltage divider bias. Please note that it has two resistors here, another resistor here, another one here. So RB1, RB2, RC, and RE. Then we have VCE at this point. And you guys, you can be able to form equations from here. Actually, the equations we have are basically VRB2. I will be using the approximation method here. I will not be using the exact method based on Thevenin's theorem. I'll just use the approximation method. And you can see from this point down to the ground is the same as this point down to the ground. So you can equate the two. VB, which is here, is equals to VBE plus IERE. That means this section and this section are the same, which is the same as VRB2 is equals to VCC times RB2 divided by RB1 plus RB2. In fact, if you look at these two, they're in series. So they're in series. And when they're in series, it means they divide this potential into two sections based on the value of RB1 and also based on the value of RB2. And that's why we are saying for you to get this voltage, just use the voltage divider rule, which says that you multiply this value together with this one, and then you divide by the sum of the two. Then that gives you the voltage at this point. The other equation you can have is the one which runs all the way down, which you usually call, we call it the collector emitter equation. And it says that VCC is equals to ICRC plus VCE plus IERE. That's what you usually have. And those are the equations I've been giving you. So let's not use the Thevenin's model. We use the approximation model, which is basically we discussed. I'm not very sure that implementation is done somewhere here. So I might require to do those equations. It's like they are not done. Yeah, let me do actually do those equations of approximation, and they will be given by VRB2, VRB2. That's a long expression. Or maybe you can put this one to be small. VRB2 is equals to VB is equals to VCC divided by into brackets RB1 plus RB2, but you multiply this by RB2. And then you put both of them in brackets like this. So you can extend. That's how you get the voltage VRB2, and which is VB actually. Sorry, the brackets are supposed to appear here. So the other equation that I mentioned was that VB, the same voltage we have there, should be the same as VBE plus IE RE. So I'm basically recording. I can put them online. Actually, I can put them in YouTube so that you can be able to access them. I have there's a channel that I've created, so I can post them so that you guys can be able to watch them from there. So VB is equals to VBE plus IERE. That's what we have for this section running down to the ground. And then the other equation, which is very important, is the one which runs down from VCC. So VCC is equals to ICRC plus VCE plus, what do you put next there? What do you indicate there, guys, after the plus sign now? What do you put there? Should be IE or what? RE, because we are looking at this voltage, and this voltage. Please note that that's what we are supposed to have. So the question is, you are given RB2 is equals to RB1. This is another exercise that I'm doing. Is equals to 5K. Then RC is equals to 2 kilo ohms. RE is equals to 3 kilo ohms. VCC is equals to this is equals to 10 volts. Beta is equals to 100. VBE is equals to 0.7 volts. Required calculate we start with IE actually is the first one you're going to get. IB, you could get IB next, or you can get IC next, no problem. IC, then you get the next value which is usually required is VCE, sorry, is what you usually calculate. So I'll give you a break. You do that exercise. Then we meet after, like, how many minutes do you think you can be able to have cleared? Hey, you guys, you look like you are not even going to do. Collins, you require like how many minutes?
We can give us 15 or 20.
Yes, please, can you take a snapshot of that question? So that it does not, it's closing in the next 30 seconds. Make sure you have them.